In this video, what we're going to do is we are going to create a simple MCP server, which is going to read CSV files. We're going to just first create a server that can read the CSV and see its contents, and then we're going to create a second tool that can aggregate a column, like taking the total sum or the average or something like this. Now, as usual, all of the files and code are available linked down below in a public GitHub repository if you want to follow along. And let me know if this is useful or interesting for you in the comments so I know whether to make more of these videos or not. So as usual, if we want to create a simple MCP server that just has, a couple tools, we don't want to yet create prompts or resources. This is something we're going to cover in a later video in the series. We need a few different things. So first we're going to create our doc string, and then we're just going to call this a CSV reader server. And you'll notice we have this autocomplete that's coming up here in VS Code. If we want to turn that off, we have to go down to the GitHub Copilot and then turn off the code completion for all files. So I'm going to do that because I find it kind of annoying right now. So we're going to do that. It can be helpful when you're working on a coding project, but when you're trying to explain something, honestly, it's just incredibly distracting and frustrating. So I'm just going to leave it off. Okay, and then we'll just say example usage. And then what is in sample.csv? How many columns are in sample.csv? How many rows are in the CSV file, for instance? So what we want to do is we want to create an MCP server where we're just going to be able to say, what is in the CSV file, and then we should be able to either implicitly or explicitly give a path to the LLM so that it can provide that as an argument, and then it can just read the CSV file from that path. Okay? So what is the next thing we need? Well, we need our imports. So we're going to need, of course, our from fast MCP, we're going to need our MCP server library. We're also going to need some other libraries. We're going to need pandas, because that is how we're going to be able to read and analyze our CSV files. And we're also going to need something called pathlib, which is going to allow us to work with local directories. All right. So if we wanted to follow some of the coding conventions that I talked about last time, we can add comments here explaining what these things do if you want. Otherwise, you can also add region imports and region, but it's not going to be necessary for this very simple example. So I'm just going to try to keep it straightforward for now. Okay. So the next thing we need to do is we need to initialize or create an instance of our server. So MCP equals fast MCP, and then we're going to give this a name. So CSV reader server. And then we have to create our tools, right? So we start this by saying @ and then we go mcp.tool. And then we define our function for the tool with its name, which will just be read CSV. And it's going to have one argument, file path. This is going to be a string, and it's going to output a string as the result. Now, that means that when we read the CSV, it's going to print a string of an output back at the LLM, and that's how it's going to handle the output. So it's not going to just, give a output in a different format. It's going to give it just as a string, even if it's giving like multiple rows of the table. So we want our doc string again, and we want to have our description for our tool. So we'll just say reads a CSV file and returns its contents. Use when analyzing CSV files or reading CSV files. Examples, read sample.csv. What's in sample.csv? And what's in the CSV file? All right. And then we'll list the arguments. That has one argument, file path, which is the path to the CSV file. Ask the user if not clear. And then we'll say outputs. And this is just going to be our string containing file info and summary information. Okay, so again, this is the name of our tool. This is the argument and its data type. Then this is going to be the output. I'm just going to check here that I'm not making a mistake. I think we need to get rid of this. And then this is going to be our description. And the description is quite important to be able to select a tool. And we have to fix a spelling mistake there, file path. Okay, so now we actually have to define what the tool is going to do. So this is when we're actually going to have our code. So what we're going to do is we're going to start off with, we're going to try to get it to read the file path as an object by taking the path of our file path string. And if we don't have it, so if the file path object doesn't exist, then we want to return an error. So we just want to say error. So the file not found, error, file not found at, and then squiggly brackets, file path object. So what are these squiggly brackets here? Well, this is actually what's called an F string or a formatted string literal. And this is actually evaluating the Python code in between the squiggly brackets. And it's a way to be able to have more concise string literals rather than having, concatenated strings together, turning this into a string and then adding it in here with like plus symbols and stuff like this. This is a much more concise way to be able to do this. And it's something that's been possible in Python for some years now. But if you're wondering why it has that F in front, it's just annotating that you're able to do this. And that's what that actually is doing. So if you're not familiar with reading code or with reading Python, this can make it a little harder to read. But then once you get used to and understand that syntax, it actually makes it a lot easier to read. So that's good. So otherwise, if we have this is basically just something that we're doing that's defensive. So that if we don't get that file path correctly, then it's going to throw an error. But if we do get the file path, then basically all we want to do is just read our CSV file. So CSV file as pd underscore or dot read underscore CSV with the file path object. So, all right. So now we're actually going to read the CSV file, or we should call this data or something. And what this is actually going to be is this is going to be a data frame. So in Python, a data frame is just a table in pandas. So it's the term for a table that's going to be read here. So we'll have columns, we'll have rows, we'll have an index. So, and actually most of the time when you're working with Python code, that's just annotated as df, which is short for data frame, so that you know. Okay? So really that's basically it. That's basically all that we need to do. So we could just output that data frame back. But the problem is that if you have a big CSV file, of thousands of rows, then that's probably going to be too big of an output for the number of tokens that you have available. So you want to try to manage the tokens and you want to try to keep your tool outputs to be quite small. Otherwise, when you're using your LLM tools, you're going to, end up having very expensive tools basically that can, if you're using Claude Desktop, for example, allow you to reach your chat limits very quickly. Or if you're using another tool that is, having some kind of other billing system, this could be, an expensive use. So you want to think about these things before you do it. So we could just stop here and just print the data frame, but that's not going to be super concise. So instead, we want to think about what kinds of questions we're trying to answer with this. So like how many columns, how many rows, what kinds of things are in it. So maybe we just want to return a summary, right? So what we could actually do is we could build a result string. So where we just say that we successfully read the CSV from our file path, so object, and then we'll just add a new line to that string. So that's with that \n. And then we'll add another line that says the how many rows there are. So we take the shape of the data frame for the first row, which is going to basically just tell us how many rows it has. And then we're going to take the shape for the next one, which is going to tell us how many columns it has. So we're going to spit back how many rows, how many columns. So we're answering some basic questions. and then we want to actually say what those columns are. So we want to actually say how this CSV is structured. So columns include, for instance, we have, and we're going to have this as a comma delimited list, where we're going to join a list of all the columns and then have some new lines. So this is basically going to put together successfully read the CSV from the file path. It'll tell us the number of rows, it'll tell us the number of columns, and then it will actually list the columns that are in the file. So columns in the file. All right, perfect. So now we maybe want to return some of the data. So let's say that we just want to return the first 5 rows. So we'll say the first 5 rows. So, and then we'll actually print those out where we'll say df head, which is going to return the first 5 rows. And then we'll just say like toString. So we're just returning this as a string basically. So this is going to actually give us a summary of our CSV file. And then we just want to return this. So we want to say return the result. And since we're trying, so we're using the try here, we want to give an exception. So accept exception as E. That might be confusing, but this is just basically saying try to do all of this. And if it fails, it means that it couldn't read the CSV. So then we want to throw an exception. We want to basically like say what went wrong. So we're going to say return F error reading CSV. And then we're just going to return that exception as a string, right? So that's basically it. We now just need our runner. So we've defined our tool. We've got our tool name, the tool argument, what it's going to output, the description, and then what it actually does. So it's going to get a file path. It's going to do some error handling. It's going to read the CSV, summarize it, and then it's going to return that as a string. All right? And then if that doesn't work, it will throw an error. And now we just have to run our server. So if name equals main, then MCP run. That's all. So that's our runner so that we can continuously run our server. We don't have the async this time, but it doesn't really matter. It's fine. So that's it. So let's just save this and let's actually test it. So let's add our server. So it's a standard input output. So we're going to add it and we're going to test it in VS Code. The command is Python. It'll be Python 3 if you're using a Mac. And we'll call this CSV MCP. It's going to ask me for the millionth time about Claude Desktop, so I'm going to ignore that. And then we want to add the CSV server. That's it. And then restart. And hopefully it detects our tools. And we have our tool detected. So for a second I was a bit doubtful. So we'll go Control-Shift-I, and we will test it. So we can see read CSV. Perfect. So let's add a sample file. So let's copy a sample file in here. This is a simple sample file of about 32 rows. And we just want to read that and see if we can actually use it. So let's go back to our MCP config. We're just going to go in ask mode. And we're just going to ask Copilot, read CSV, what's in sample.csv. So if this worked, then it should prompt us, and it indeed does. So it finds the path on its own. So I didn't have to give the path. It knows it because it's having this in context here. And then we're going to allow it in the session. We can actually see it gave the file path, and then we can see our output. So we can see that we successfully read the CSV from this path. We see how many rows, how many columns, what columns there are, and then it gives these first 5 rows in the CSV. Perfect. And then it summarizes these things, and we're using the Claude Sonnet 4 model. So it gives the column structure, sample data overview, and so on. Okay, now what if we want to actually add some of these columns? Like we have units sold. So what if I ask it, read CSV, what are the total units sold? Will it be able to answer that question? So here it's going to give us a whole bunch of code and it's going to explain how we actually do this. but you see that we only have the first 5 rows. So sometimes it's going to be smart and it's going to point out that it only has the first 5 rows. However, it doesn't do so very concisely. So you might think it's not working, especially if you don't understand the underlying code. So it's very important to understand what your tools are actually doing. If it's returning a summary or a sample of the data, that might be one of the reasons why you're getting some unexpected results. But basically it can't read this information. So even if I open a new window here and then I say read CSV, what are the total units sold in sample.csv? Sometimes it will actually give you an incorrect result. So in this case, now we're getting consistently that it's doing this. We'll try maybe for another model, see if we can do that maybe with Gemini 2.0. So we'll try that again. So read CSV. What's the total units sold in the sample file? CSV file. Okay, and it's just going to give us a whole bunch of Python code back. So it's not actually going to try to do this. So how do we actually get it to answer this question? Well, we have to create another tool. So we have to create a tool that's actually going to be able to aggregate this information. So let's go back to our server. Let's actually stop the server here because there's no point in running it. We're not using it. So we're going to go back and we're actually going to, right here, we're going to create a new tool. So let's use that syntax, MCP tool. So what do we have? We have our definition of a function, which we're going to give the name, like aggregate CSV, and we're going to have different arguments this time. We're going to have our file path. We're going to have a group by, because we're going to have to group by something to give that capability to group by a particular column. We want to have an aggregate column. And we're going to have a aggregate function, like sum or mean or whatever. Okay? And we're going to output this as a string. We're now going to have our docstring, and we're going to say that this is a function for aggregating data. So aggregates data in a CSV file to return the total, mean, etc. for a column, for columns. And then use when calculating totals, averages, we'll even do counts, other stats, etc. And examples, sum sales by region, if the total units in sample.csv, what's the units sold by product. And then the arguments, in this case, we have 4. We have our file path, which is the path to the CSV. We have our group by, which is the column names to group by. And then we'll say that this is use comma separated for multiple. And aggregate column, column name to aggregate, and aggregate function, aggregation function to apply, like sum, mean, count, min, max, standard deviation, whatever. Okay, so that's it. So again, name, arguments, description. Now we'll actually try to do some stuff. We'll say we'll have the file path object again, so we'll try to get the file path object. So equals path of file path. And then we will have the aggregate function, and we'll do something here where we'll make sure that it's lowercase because it needs to be in Python. And then we'll just have the same code as before, where we'll just say that if we don't have the file path object, then we'll throw an error. And then we'll read the CSV. So pd read CSV for the file path object. Right? So now we have our data frame, and we're actually now going to aggregate it. So in order to do that, however, we need to do some handling of the arguments. So for example, we said that we would have multiple columns that are comma delimited. So how do we actually deal with that? Well, we actually have to get a list of these group columns, and we have to say columns for columns in group columns. If the column is not in, oh, whoops, I was adding the wrong code here. So how do we actually do that? Well, we have to actually take the column and we have to strip spaces around it for the columns that are in the group by columns, which we're going to split by the comma. So this is basically splitting them up by the comma into a list. So if we have a string that has, for example, like product and category, what it's going to do is it's going to split it up here so that we have product category, and then the strip is going to remove the extra space. And then we're going to have an array of, or a list of these two columns, and that is going to be an example of what we would have here in that instance. Okay? So that's going to give us our group columns. But now what happens if these columns aren't actually in the table? Well, we could add some kind of like defensive programming to be able to throw errors if they're not found. But just to keep things concise, I'm going to leave that out. So we're just going to assume that the LLM can handle that. But in reality, it might be a good idea to have those errors in case we're asking it for columns that don't exist. So if we were to do that, we would just add this here to basically say, you know, what are the missing columns, where we're checking the grouped columns to see if they're in our data. And if they're not, then we're grabbing them. And if these exist, basically, if we end up finding some missing columns, then we want to return an error. So same thing for the aggregate column. If it's not in our data, then we want to throw an error. So this isn't necessary, but it's something that is just a good idea to have. So I just copied it from the complete code just so we can move on. So now we want to tell it how we can aggregate the data. So we want to give it a list of our valid functions. And this is also controlling what the possibilities are. So we're just going to give it a few. We're just going to say sum, mean, and we're just going to say, we'll leave count out of this for now. So we'll have minimum and maximum. And I'm going to remove the counts and standard deviation from here, just to keep it simple for the demonstration. And I'll explain later how we would handle count, because it actually complicates things quite a bit. So again, we want to say if the aggregate function is not in the valid functions that we've defined, then we want to return an error. So invalid function. Okay. Perfect. So now what we want to do is we want to actually perform the aggregation. So we want to get the aggregation results, which is how we just group our data by the columns for the aggregate column. So we're going to basically grab the columns that we want to group it by. We're going to group the aggregate column. This is what we're actually aggregating. And then we specify the aggregation for the aggregation function. So we basically have built this kind of dynamic aggregation, and then maybe we'll reset the index. So it's not going to have the numbers of the rows, the same numbers of the rows as was in the original table. Okay? Then we want to just be able to say what the aggregate column name is in that new column is just the aggregate column. Okay? All right. So that is all for now. We have to take that result and we have to actually return it. So we'll say the result is that the we have analyzed our data. So aggregation completes. And we're going to add another line that just says file path object with a new line. we'll say that we grouped by, again, we're just basically going to indicate what columns we actually group the data by. So group by columns, whoops, group columns, and add another line. And then we want to specify the aggregation. So aggregation for our aggregate function and aggregate column. And sum of rows, something like this. Okay. So aggregation, for example, we took the, this is the sum, for instance, and then we have here like the sum of rows, for instance. So then what we're going to do is we actually want to take those results and we want to return them back. So in this case, we're going to actually just return the aggregation result as a string and ignore the index, which is just going to be the number of rows. So it's going to be the number for each rows. We reset that up above. And in this case, we're taking the full aggregation result. So we're assuming that we're aggregating it down to a smaller number of rows, small enough to be able to handle here. And that is basically going to be it. So then we want to make sure that we return the total, and I think that's all that we want to do. So we'll just take the total here, and we'll say the total is the aggregation result for the aggregation column name. And we will say aggregation function. So that is it for now, I think. So then we just want to return that. So if the total is not none, then we're going to add that to the result as well. So we just want to have our f string. We want to have some new lines, total aggregate function, and then we just have the total, where we want to format that with, for example, 2 decimal places, and that should be sufficient. So then we just want to return our results, I guess. So return results, and then throw an exception as E, return F, error, aggregating file, and then return the exception. Okay, that's it. So in summary, what we have done here is we are reading our CSV from a file path. That's the same as before. Then we are actually gathering our additional arguments. So we have 3 additional arguments. We have a group by, we have an aggregate column, and we have an aggregate function. We need to be able to say what we're grouping by in order to do the aggregation. We're going to specify what actual column name we're aggregating, like the units sold or the sales, because we could aggregate different things. Then we want to aggregate it in what way, like sum or mean, for example. We didn't include counts here, but in the repository, I'll explain how to do that. But that's maybe something you want to try by yourself, because you have to handle counts differently than with this logic. So then we want to handle the group columns. We want to take this comma delimited list, split it up, and then we want to remove the empty spaces. We're using something called list comprehension, so that is how this works. And then we want to validate that those columns exist. So to make sure that we have the columns that we're referencing, or whether there's any that are missing, both in terms of the columns that we're using to group the data and the columns that we're using to specify that we want to aggregate. We also want to make sure that we're specifying a valid function for our aggregation. And this is particularly important because we've only specified 4. So if we ask it to take the count, it won't be able to do that. So we want the LLM to be able to get the error back. Say invalid function. This tool only supports sum, mean, min, and max. And then I should actually just use the f string for that. Only supports valid functions. Okay. All right, and then what we're going to do is we're going to perform the aggregation for those grouped columns for the aggregation column that we're specifying, like units sold, for instance. So if we're telling it to group, give us the total units sold by category, it's going to group by category for the units sold, and it's going to aggregate it by the sum in that case. And then it's going to make sure that it gets that total sum, and we're just going to summarize all of these results as well as get the grand total. So if all we wanted was the grand total, then we would just do this instead of all of this group by, and we wouldn't even need those group columns. But we need to anticipate that it's likely that someone is going to want to ask for a total for one or more columns. So we're just building that functionality into it, and then we're returning that result back. So how this is going to work is we're going to be able to read the CSV file, and then we'll be able to aggregate it once we see the contents. So let's go to our server, and we're going to start the server. So if we have done it properly, it will register the tool. And then we can test it with a new chat, and we can say, with our aggregate function, calculate, so what are the total units sold by category in sample CSV file. So now let's see if it works. So we see that it's prompting us to use our tool. So it registers that tool, so that's fine, that's not surprising. And we see that it can't find the column category. So the column category was not found in the CSV file. So what's actually interesting there is I would expect it to actually use the read CSV and then use the aggregate. So let's use the read CSV first. What's in the sample CSV? So we can see that information. And now it's able to actually see the total units sold, which is interesting. So it ran the read CSV, and once it was able to see that, then it just calculated on its own what the total is by category so that it could find the appropriate thing. So we see here that the problem was that it was selecting, it was a casing problem. So that's probably something that we would want to handle in our tool to be able to make sure that the casing is going to match so that the user doesn't have to specify the exact casing. However, we can also just try to set it up so that it's always going to use the read CSV before aggregate CSV. And as you see, then the LLM can handle that. So let's try it one more time, and let's try to see if it gets it right on its own. What are the total units sold in the sample.csv? So, okay. Previous attempts failed due to invalid. So you see here that it's trying to group by none. It's trying to group by empty string. And here that it read the CSV file and it tried to understand it. And we see that it's having an issue that it's expecting a valid column to group by or no grouping at all. So you see here that it's actually trying to group by none. So what we could actually do is we could actually modify our MCP server code where we could, after we read the CSV file, we could actually add a column, none, and we could just give this as none or all, for instance, so that it can actually perform that group by. So let's see if this actually allows it to do what it was going to do. And it's interesting because this is quite a different result, I noticed, with GPT 4.1 as for Claude Sonnet 4, but we'll examine that later in a moment. So this is just showing the kind of different results you get depending on the model you're using. So the goal here, what we were trying to do is to just get the total. So it can get the total if it just selects a column, but it just kept trying to not select a column, but this is a required argument. So that's why it kept getting these errors, is because the column wasn't being found. So what we're going to do now is we're going to try again, and we're going to say aggregate CSV. What are the total units sold in sample.csv? and it's running it over and over before it finally gets the result. And the reason why is because it was able to run it here by product. So this actually, the change that we made didn't actually solve the problem at all. It kept trying to group by an empty string. Maybe if we group by the empty string, then group by units, that's quite dumb. So I'm going to make one last change, and then we're going to experiment with Claude Sonnet instead of GPT 4.1, and I'll show you how it's so much more different. Because here it's calling the tool a total of 4 times to get this result, and it had errors before. And in Claude Sonnet, you'll see that it takes a completely different approach. So we're going to restart our server again. So with the empty string that we've added to see if that works. I have no idea if it's going to work. I'm just kind of experimenting live. And we'll say again, aggregate CSV. What are the total units sold in sample.csv? So, and here it was able to get it by grouping by the empty string column. But I would say this is not a pattern that you would want to do, especially here it's trying to do this multiple times and then it's getting an error. So aggregation column units not found because it needed to read the CSV first. So we were able to help it be able to, read from the total. But let's just comment this out and restart the server. And let's look at how this works with a different model. So let's, instead of GPT 4.1, let's use Claude Sonnet 4. And let's just ask it, aggregate CSV. What are the total units sold by, we'll just say, what are the total units sold in this sample file? We won't even say the CSV. Okay, so it right away reads the CSV, and then it aggregates it, and it gets the total. So you see here that it's trying to perform the sum. It runs the group by, and then it immediately sees that this doesn't work, and then it's going to try to group by product. So this is different from the approach of GPT 4.1, because GPT 4.1 just kept running into errors and then kind of just gave up. We saw that one of those times it was able to run into product, but after running the tool 4 times, we see that this kind of like reasoning flow is much better with Claude Sonnet. And in general, I've noticed that I do get better results when I'm using that model. But that of course makes sense because it is a newer model. So, but this is just to demonstrate that you really want to kind of think about the capabilities that you're putting into it and which arguments are going to be mandatory, which are not, and how you're going to handle these edge cases. So you really have to think about what people are going to do with your tool and how you can build it in order to enable that. Now, before we move on, of course, we have to validate, is 92 correct? And indeed, if we look at our good old Excel and we look at all of the units sold in the sample file, we do indeed have 92 units. So it is correct. Always important to validate. So this is VS Code. Now, how do we get this working in Claude? Well, I think I have the Claude, no, I don't have the Claude config open here. But what we're going to do is we're going to open Claude, or maybe I can open it recent and Claude desktop config. So I'm going to just specify the CSV MCP from the actual lesson files. So this is the one that you'll be able to download. And once you have this set up, then you need to run it with the command line. So I've already run it. So we're running our CSV server. You can't run it from VS Code. You have to run it from our command prompt. And so we launch Claude Desktop and we see that we have our CSV MCP. So we have our 2 tools. And now we can actually try to read it. So we can ask it, for instance, what is the average units sold by category in sample.csv. And notice we didn't say the path, and Claude is not like VS Code where it has one of our folders open. So it's not actually going to be able to find this. So it's first going to try without a file path, and then it's going to actually ask us to give the file path, which is a nice experience. So I'm going to copy the path and I'm going to give it the full path for the file, and it's going to use that to try again. So it's going to use that in the argument. It's going to read the CSV file. And once it sees the information, it'll be able to know what columns are there. So category, units sold, mean. And then it'll be able to give this information back to us. So electronics and furniture. And then I can ask it, can you make a concise and easy to read bar chart that shows this comparison between the categories? And again, this is going to be one of the benefits of Claude Desktop, is it can make artifacts, which are actually going to be visualizations or diagrams, and those can even be interactive. So while it's doing this, I'm going to summarize what we've done. We've created a very simple MCP server, which just has one or two tools. One tool that is going to allow us to read the CSV file and work with it, and a second tool that is going to allow us to aggregate columns. Now, the key learnings here is that when you're defining the code, which is going to be, what the tool is actually doing, that you really have to kind of think about what people are going to do and how you're going to be able to return the right result. You don't just want to spit out the raw result back at them, because then it could be too many tokens, it could be too inefficient, and you could be relying on the LLM to do the work, like the math, which is not going to work out well. And you also don't want to make it too rigid, because then it will run into issues like not being able to group by all, for example. So you really want to think about how you set this up to try to make it as efficient and flexible as possible. And it's not something that's easy. It's also not something where there's one right answer. It's really going to depend on the scenario. But this is why making your own MCP server is so cool and useful, is because you can define what works best for you in your scenario, and then create these kind of custom suite of servers to help you do your analysis. So we got our visualization here, average units sold by category, where we're comparing these two categories. We have it working in VS Code. We have it working in Claude Desktop. Again, VS Code, great for testing our server to make sure it's useful and it's working. Claude Desktop, much better for actually consuming it and performing the analysis. So that's everything. That's everything I had to say. Have fun, I guess. See you in the next video, and I don't know, whatever.